Hey guys, it's Mr. Ray here. Our next math lesson. This will be the last lesson from the trigonometry unit. It's probably the most important lesson, and in a lot of, if I was teaching this in a classroom, I'd probably teach this over two days. So I'm combining it into one lesson. I don't normally like to do this, but everything is very closely related. So it's going to take a little bit longer than normal, and that's why this is the only lesson of this week. So your assignment at the end of the week will just be pretty much based on this lesson and maybe a bit of Pythagorean theorem, lesson 3. I don't think I had any questions on that in the last assignment, so it'll just be a little bit from lesson 3, but mostly from this lesson. Okay, so this is a this is a topic that you're going to need to know this in grade 11 for sure, and if you go on to grade 12, it'll be there as well. So please take the time to do the homework in this section. At least try some questions. It's not enough just to look at what I'm doing and just say it makes sense, because unless you try it yourself and go through the process, you're not really learning it. So this lesson's actually 5 pages. I think it's like 7 examples. So let's get started. So for all these problems in this lesson, they all involve right triangles. Okay, so what we're going to be doing is finding unknown sides or angles in a triangle that has a 90-degree side. Okay, so you won't get any questions where you don't have a right triangle, and I won't ask you what the missing sides or angles are. That's another topic. It's learned in grade 10 academic and grade 11 mixed math and college math, but not in grade 10 applied. So we can narrow this whole thing down to every triangle you see will be a right triangle. Okay, so let's talk about how we can name the sides. Very important first step. Okay, so this is a typical right triangle. We've got the 90-degree angle that's always got a square in the bottom, and you've actually got 2 other angles. Okay, there'll be acute angles, meaning they're both less than 90 degrees, because together these 2 angles have to add up to 90 degrees, so the whole triangle is 180. Okay, so if I'm naming these sides, you guys already know that the side opposite the right angle is called the hypotenuse. Okay, so that goes without question. That's nothing new. But we're actually going to name the other 2 sides. Now, when we did Pythagorean theorem, it didn't matter what those 2 sides were called. We just called them legs, or just the 2 other sides. It didn't really matter which one was which, but it does in this lesson. Okay, now how we name these 2 sides will depend on which angle we're looking at. Okay, it'll be one of the 2 acute angles. Okay, it'll never be the 90-degree angle. So for example, in this corner here, I have it's a Greek alphabet letter called theta. Okay, that's just like we use X all the time for unknown sides or things like that. We use this letter, and it's a little hard to see there, but kind of looks like a bit of a half smiley face with a kind of an oval circle. So that's the angle we're interested in, not this one. Now we could change it, and I'll show you how that changes the sides. So if I'm looking at this angle, maybe they gave it to us, maybe they want us to find out what it is, but that's the angle we're interested in. Okay, if I look straight across to the other side, well, that's opposite the angle, so we're going to call it opposite. We can shorten it to OPP or O. We can shorten the hypotenuse to H. And then the third side, it's always the last side, is called the adjacent. Adjacent in English means next to. So adjacent side is next to the angle, like it makes up the angle with the hypotenuse all the time. Okay, so that's always the first critical step, is naming the 3 sides. You have to know which angle you're interested in. Now, if this picture was different, if that theta was up in this corner, Well, this would still be hypotenuse because it's still opposite the 90-degree angle. But if that's the angle I'm looking at, now this is the opposite side and this becomes adjacent. So these two opposite adjacent sides will flip the names depending on which of these two angles I'm interested in. Okay, so now that we've named the sides, we actually have three ratios. So a ratio is just like one number divided by another number. Okay, so we have three possible ratios. We've got three different sides. I can take a pair of these sides and make a ratio. Okay, so I could use opposite hypotenuse, I could use adjacent hypotenuse, or I could use opposite adjacent. Okay, so in math we have a predefined name for three ratios of the three sides. Okay, so the first one is called the tangent ratio. We shorten that to tan. So the tan ratio of that angle is going to be represented by the opposite, the length of the opposite side divided by the length of the adjacent side. Okay, so tan theta, tan of the angle is opposite divided by adjacent. The next angle ratio we have is called the sine ratio. It's not sin, it's sine, it's shortened to SIN. Sine ratio of the angle theta is opposite over hypotenuse. Okay, and then the third ratio that we're going to be looking at is called the cosine. We shorten that to cos, C-O-S. That ratio is using the adjacent side and the hypotenuse. Okay, now this can be very confusing to try to remember, and in fact I never really memorized this. What we have here, if I skip down a couple of lines, we have this made up word or name, SOHCAHTOA, SOHCAHTOA. So if I write that out here, this will be your best friend for this lesson. Okay, so if I break that up into three-letter acronyms, okay, if you notice the first letter in each of the three-letter combinations, S, C, T, well, that's the names of these ratios. So this is the sine ratio, this is the cosine ratio, this is the tan ratio, and then the second and third letters of each defines the sides that we're going to use. So for example, I could say, oh, you could just write this out or say it in your head, say it out loud. From this you could say sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan ratio is opposite over adjacent. Okay, so that allows you to remember these three ratios and then use it in the calculations. Okay, we call these three ratios the trigonometric ratios, and that's what the title of this lesson is. Okay, remember the word trigonometric. I think I might have said this at the beginning of the unit. This is what trigonometric means, is the measurement of information in a triangle. So finding the measurements of the three sides and the three angles. So that's all trigonometry is taking a triangle and finding unknown side lengths or angles. Okay, and that's what these ratios are going to help us with. Okay, now we also have something called inverse tan, inverse sine, and inverse cos, but rather than confuse you with all this at once, when we get to a question that involves it, then I'll talk about what that is. Okay. So it's always going to be, these questions always will involve a right triangle. A lot of times the triangle is drawn for you, sometimes it's not, but most of the time it is. Okay, so here it says find the length of side AB. So there's AB, and they've already labeled it with an X, which is nice of them, to the nearest tenth of a centimeter. So what have they given us? Well, we know it's a right triangle. They've given us this angle C, which is 37, and they've given us this side length AC of 11 centimeters. Okay, so the first thing we do is we label the sides, just like we did at the beginning of the first page. So they gave us 37. That's our angle that we're interested in. That's the angle that we're using. Okay, so in terms of naming the sides, well, it doesn't matter where the angle is. This side here, the 11 centimeters, AC, that's the hypotenuse, so I'll put an H there. And since I'm using this angle, that means this side over here is the opposite side, so I put an O there, and that leaves this side as adjacent because it's next to the angle. Okay, so now comes the critical part, because we're going to decide at this point which of those three ratios we're going to be using. Okay, so they've asked us for this side here, AB. AB, they've labeled it X, but that's the opposite side. Okay, so I'm definitely using a ratio that has opposite side in it. So maybe I'll just write this out again. SOHCAHTOA. Okay, so I know the ratio is going to have an O, so it could be sine and it could be tan. It's definitely not going to be cosine that we use, because cosine ratio does not have that side in it. Okay, so how do I know the other side? Well, the other side, if I don't know this side, then I have to know the other side. I can't have two unknown sides. So that narrows it down to just hypotenuse, because they've told us that this side is 11, but we weren't told what this side is. So that tells us the ratio we're going to use involves the opposite side and the hypotenuse. So I go check that. That's the sine ratio. Okay, so as soon as I figured that out, I write sine, and then the sine is a function, a math function, but we need to know what angle we're talking about here. And the angle we're talking about, well, first of all, it's going to be this angle here, C. We'll change it to 37 on the next line. So sine is opposite over hypotenuse. So I'll just write the words first. Now the next line, I'm actually going to change these three values to what the diagram shows. So instead of C, we know that C is 37. So sine 37 degrees is equal to opposite. Now opposite they've called X. So I'll put an X on the top there. And then hypotenuse we know is 11 centimeters. So I'm not going to put centimeters there. I'm just going to leave it as 11. Now if you remember from your equation solving, I'm trying to solve for X. Okay, so what's being done to the X right now is we're dividing X by 11. So to undo that, we multiply both sides of the equation by 11. So when I do that, 11 times sine 37 is equal to X. Okay. Now, when I multiply this by 11, okay, you notice I put the 11 to the left of this, and that's important because if I wrote it as sine 37 times 11, you might think, well, I should multiply the 11 with the 37, then that would be a big mistake because you don't do that. Okay, so if you're multiplying one of these ratios, almost think of it like brackets. You put the number you're multiplying by to the left. Okay. All right, so let's, at this point, you should bring your calculator out. This is a very important step, okay? So, you notice somewhere in your calculator, you've got these three buttons, and you probably noticed them before and never knew what they were for. Sine, cosine, tangent. Those are the three ratios we just talked about, SOHCAHTOA. Okay, so we're going to be using those buttons. Now, one thing that's important about trigonometry is it involves angles, and angles can be measured different ways. Just like temperature can be measured in Celsius and Fahrenheit, there's another way of measuring angles using something called radians instead of degrees. So if you accidentally have it on the wrong unit, if you had it on radians, all your calculations will be totally wrong. Okay, so every calculator is different, but on the iPhone here, you notice I got a button at the bottom in the corner that says rad. Okay, if I press that, you see the RAD shows up on the top of the screen, and now this rad button changes to a degree button. So I've actually got it in the wrong position right now because it's going to use radians instead of degrees. So I go back, press degrees, Unfortunately, it doesn't show degrees up here. I don't understand why they didn't do that, but you have to make sure your units are right. If you have a kind of a standard calculator, you'll probably see at the top, it might say D, R, or G, or DEG, RAD. Make sure it's on D or degrees, okay? And if it's not, you're going to have to figure out how to change it. Every calculator is different. I can't tell you which buttons to press, but sometimes there's a DRG button. You press that and then you choose the units. Okay, so if that doesn't help, you can always look up online, find the model of your calculator, do a Google search on that model and a user manual, and that might help you, or talk to your parent or maybe an older brother, sister, or friend. Okay, so how do I solve this? Well, I have to find sine 37. I'm going to do that actually first. So on this calculator, see my reflection, light reflection there. The way I have to do it on the iPhone is I press 37 first, and then the sine button. Okay, and I get this decimal. Okay, that's actually the value of sine 37, and then I multiply, so times 11 equals, and I get 6.6199. This says find the length of the side to the nearest tenth, so the tenth would be there. Do I leave it at 6.6 or do I bump it up to 6.7? Based on the 1 there, I leave it at 6.6. So x is equal to 6.6, and the units were centimeters. Okay, so that answers the question. The question was, what's the length of AB? Or I guess I could actually, therefore, side AB is 6.6 centimeters. That would be acceptable for me if you put that, because they put X on the picture. But if you came up with that yourself, if you labeled that as X, then you'd have to put this as well. Okay. All right. So make sure that you're trying this calculation as we go along. Make sure you know how to use your calculator. There's nothing more frustrating than thinking you know what to do, and then when you try it yourself, nothing's working, just because you're using the calculator incorrectly. Okay. All right, example 2, let's go fly a kite. So Jamie's kite string is 35 meters long, so Jamie's down here, kite string's up there, there's the kite in yellow. It makes an angle of 50 degrees with the ground. Okay, so 50 degrees from there up is the kite string. What's the horizontal distance between the kite and Jamie? Okay, so horizontal distance is left, right. So if we draw this triangle here, this would be the vertical distance, or the height of the kite, and this is the horizontal distance. So we could answer the question, how high above the ground is the kite, or we could answer the question, how far horizontally away is the kite. Okay, so we do the same thing we did last time. We start labeling our sides. So there's our right angle there, so that makes this the hypotenuse. Here's the angle we've been given, or they might ask us an angle. That would be our angle of interest. In this case, that's our angle of interest. So this would be opposite, and this would be adjacent. Okay, so as soon as you've done that, you go back and go, what are we trying to find? We're trying to find x. X is the adjacent. So for sure, our ratio that we pick will have to have an A adjacent in it. Okay. So again, you don't have to do this every time, but let's do it. So we know since our ratio has to have an A, it's either going to be cosine ratio or tan ratio this time. Okay. Now to figure out which of those two it is, well, we know the other side, we have to know the value. We don't know the height here, the opposite side, but we do know the kite string is 35, that's the hypotenuse. So our ratio will be A and H, so that makes it cosine, that we're going to use. Okay, so again, we start off by doing our equation. So it's going to be cosine of the angle we're using, So this time I'll put the 50 in directly. Cosine of 50 is equal to adjacent over hypotenuse. Okay, and adjacent side was x. That's what we're trying to get. Hypotenuse was 35. Okay, and we want to figure out what x is. We're going to solve for x. That means we multiply both sides by 35. So 35 times cosine 50. I'm just putting into brackets so that you know we have to do this first. Is equal to x because we multiply this by 35. The 35's cancel. Okay, so back to the calculator. Cancel everything. Just make sure it's still in degrees. Okay, so this time I'm going to do cosine of 50 and then times that answer by 35. Multiply. So this calculator, I put the 50 first and then I press the cosine button and then times 35. And I get an answer of 22.4975. Excuse me. They want to know to the nearest meter. Okay. Now this is almost halfway between 22 and 23 meters. 22.49 is about as close as you can get. So in this case, I would actually, the true answer would be 22 because you'd have to round down. Okay, because when you look at this, you're looking at just the 0.4, and the 0.4 is the 4 is less than 5. So the true answer would be 22, but in this case, I personally would say 22.5 meters because it's almost exactly 22.5. So that's our answer, but that wasn't what the question said. The question said, what's the horizontal distance between the kite and Jamie? That's represented by x, but I want to make a word answer. This is a word question. Therefore, and you can just basically read back the question with the answer. What's the horizontal distance between the kite and Jamie? Therefore, the horizontal distance between the kite and Jamie is 22.5 meters, and just so I don't lose rounding marks, I might say 22 meters if you want to be picky with the rounding up here. Okay, so that's fairly similar to the last one. We're trying to find a side, knowing in both questions we knew the one angle and we knew one side. Okay, so we used cosine ratio this question, we used sine ratio in the first one. So hopefully you'll see, every time you get a question, you label the sides first and then figure out which ratio you're going to be using and then solve the equation that you build. Okay, so this one's an escalator. Jay is supervising installation of an escalator at a new office building. The escalator will make an angle of 30 degrees. So there's the escalator going up. So they've actually formed a triangle kind of right below. So you've got kind of the horizontal distance, the vertical distance. This side here is the hypotenuse, but it's kind of how long the actual escalator is. And this would be the angle that the escalator is going up. Okay, so they've told us that the height of the escalator, so let me read this, the escalator will make an angle of 30 degrees with the ground, so there's our angle, and will rise vertical distance of 20 feet, so that's this side here. Okay, so we got our 90-degree angle there, so that makes this side the hypotenuse. This side is opposite the angle, so this is our opposite side, this is our adjacent side. Okay, now when they say what's the length of the escalator, that will be this side here. So we can call that x for now. Put it here or up here, doesn't really matter. So we definitely are going to be using hypotenuse because that's the side they want us to figure out. What's the other side we're going to use? Well, it has to be a side that we know the length of. And so it can't be this side. It has to be opposite because we know that's 20 feet. Okay. So again, SOHCAHTOA, we are going to use opposite and hypotenuse. So OH, it's got to be that one, which is sine. So start writing it out. Sine of the angle, 30 degrees, is equal to, this time I'll just go, well, that's opposite over hypotenuse. So opposite is 20, hypotenuse is x. Okay, now this is, you've seen this before when we did solving equations. What happens if you get a fraction and the variables on the bottom? Well, you know, we're used to maybe having x over 20. We multiply both sides by 20 and get our answer. But in this case, you can't, if you multiply this by 20, you're going to get 400 over x. It's going to make it worse, okay? So what we're going to do, we're going to multiply both sides by x. So x times sine 30. Now when I multiply this by x, it cancels the x's out, so I just left with 20. And now I can get x by itself by dividing both sides by sine 30. Oops. So if I divide this by sine 30, I just have x left over. And over here I have 20 divided by sine 30. Okay, so this is a little different because the other questions we multiplied sine of a value with a number. This time we're dividing. So you have to be careful with your calculators on here. So definitely try this on your own calculator. Make sure you get the right answer. Okay, so this time I'm going to be super careful on this one. I'm actually going to use brackets on the calculator to make sure that this number is calculated correctly and I don't do things in the wrong order. So I start off with 20, then divided by, and now I'm going to put some brackets. Left bracket, and now I do the 30 sine. 30 sine, then I do the right bracket, and then equals. Okay, and it's exactly 40. So x is equal to 40. So therefore, what's the length of the escalator? Therefore, the escalator is 40, and the units, because that's given in feet, well, so is this answer, 40 feet long. Okay. Now this question here, it's kind of a throw-in. It's basically converting the speed of the escalator so that you know how long it will take to get to the top or the bottom based on the speed. We just figured out that it's 40 feet long. And we're told that the escalator travels at 100 feet per minute. So since we only have to travel 40 feet, it's definitely going to be like less than half a minute. So somewhere under 30 seconds. So in order to get that ratio, this may be something you might have seen in science class. So this is in relating distance, speed, and time. I'm not sure if you've ever seen that, but based on this, you could say that we're trying to figure out the time it takes. So I want a formula for time. So look at time. Well, time is going to be distance divided by speed. Okay, so t equals d over s, and we know the distance that we're traveling is 40 feet from here, and the speed is 100 feet per second. So that's going to be equal to 0.4. Now what are the units for this? Well, the time is based in minutes because it's 40 feet per minute. So 0.4 minutes. Now, if you want to calculate that to seconds, so there's 60 seconds in a minute, so you'd multiply 0.4 times 60 to get the number of seconds. and that works out to 24 seconds. Okay, so therefore it takes 24 seconds to use the escalator. Okay, don't worry too much about that. That's kind of a throw-in question. That's not even trigonometry here. This is just converting, calculating the time from the distance and the speed. This is the important part of the question here, where you're calculating one side of the triangle. Okay, so let's go to example 4. Hopefully you're seeing the pattern here that we're doing. And so far we've got pictures of triangles in every single question. So that happens a lot, but not all the time. Okay, so in this case, in this question, a storm has caused a 13.5 meter hydro pole to lean over. So there's the pole, it's obviously leaning. The length of the pole is 13.5, so that's why that side is there. The top of the pole is now 11.8 meters from the ground, directly above the ground. Okay, if it's standing straight up, it would have been 13.5, but it's obviously closer to the ground now. And in this question, they want to know the measure of the angle. Okay, so this is the first question we've had where we're trying to find an unknown angle. Okay, so I'm going to call that theta. That's just my personal choice. You could call it angle P, you could call it X if you want, but it's definitely an angle. Okay, now if I'm interested in knowing that angle, now when I name my sides, obviously there's your 90 degrees because it's straight with the ground. This will be the hypotenuse. This will be the opposite side, and this will be the adjacent side. Now, since we're trying to find an unknown angle, whenever we do that, we have to know the two sides we're using. Okay, so write it out again, SOHCAHTOA. So in this case, we know the hypotenuse side, we know the opposite side. So the only way we can get that angle is if we use the ratio with H and O, and that's our sine ratio. So now I write this time I put sine theta because I don't know what the angle is. I'm going to actually solve for that. And that's going to be equal to opposite over hypotenuse. So sine theta is equal to 11.8. And make sure your units are the same. Otherwise, your answer will be wrong. 13.5 meters. Okay, so at this point, you could actually calculate that. You're going to get a 0.9 or 0.8 something. But that's not the answer because we're trying to find theta, not sine theta. Okay, so here's where these inverse functions come in. I said I'd talk to you about it later. That's what I'm going to do now. So I just want to do a little side note here. So you guys remember if you had something that said x squared equals, let's say 25. If I want to solve for x, we have to do the opposite of what's going on here, right? So right now it's squaring, and the opposite of squaring is square rooting. So what I can do, I can square root both sides. So I've done the same thing to both sides, but the reason why I did that is because the square root and the square actually cancel each other out, and I get x equals the square root of 25, which is 5. Okay, so hopefully you've done this before. You had to do something like this with Pythagorean theorem. Okay, so there's a similar strategy here. So we have to undo this sine thing. Okay, and the way we do that is with something called sine inverse. Sine inverse means it's the opposite of sine. Okay, so the way that's written is, you see it on the first page. See if I can pull that up. Okay, so there's the tan inverse function. So it's written tan it looks like an exponent -1, and cos, that's cos inverse, and that's sine inverse. Okay, so we're always going to have to do one of these three if we're trying to find an unknown angle in a triangle. So in this case, it's obviously sine inverse. So what I'm going to do is do the sine inverse of both sides. So take the sine inverse of sine theta, take the sine inverse of 11.8 over 13.5, and just like the square root and the squaring cancel each other out, and you're just left with x, same thing happens here. Sine inverse and sine cancel, so I just have the angle left, theta. Still have a sine inverse over here, but I'll show you how to do that. Okay? All right, so go back to your calculators. Now, since this is sine inverse, we can't just use the sine button because that's not the same thing. Now, on just about every calculator I've ever seen, the sine and sine inverse buttons are the same button, but they usually have like a second function. So hopefully you can see that on yours. Now you can't actually see it, you have to know it on this. So to get sine inverse, I'm not actually doing the question yet, you'd press on the iPhone, you'd press second, because that's second function, and you notice all these sine, cos, and tan buttons are now the inverse. So this would now do the inverse of sine, cos, or tan, depending on what button I pressed. Okay, so that's how we're going to do it. So the first thing we have to do is do this division. Now I wouldn't do this separately in two lines, I do it in one step. So this is what you do. So you start off 11.8 divided by 13.5 equals, okay, and you get that decimal. Now you do the sine inverse. So I've still got it on the second function. So now I just press the sine inverse, and I get what looks like a reasonable angle, 60.9, and it says rounded to the nearest degree, so it's either 60 or 61. It's going to be 61 because that's a 0.9, so theta equals 61 degrees. Okay, and then I've done all the math work. Now I just have to answer the question. Find the measure of the angle between the hydropole and the ground. So therefore, the hydropole and the ground are at a 61 degree angle. Okay? So that's how you find unknown angles using trigonometry. You notice we still start off with like an equation using sine, cos, or tan. We filled in what we knew, but in this case, the thing we're trying to find is the angle. So we have to do the inverse function of whatever ratio we wrote the equation for. Okay, if this had been cos theta equals something, then we would have done cos inverse to both sides. Or if it was tan theta equals something, we'd do tan inverse to both sides. Okay? All right. So I think we've got 3 more examples. So hopefully you can hang in there for the last 3. The more these you do, hopefully the more straightforward it becomes, because we're actually doing the same process each time. I hope you can see that. Okay, Anisha stands 14 meters to one side of the top of Kakabeka Falls. Her line of sight. Now this isn't the best drawing, I don't think so. Really what this is here, this is the waterfall here. Okay, so the water's going down at 70 degree angle. What's the height of the falls? So she's over here 14 meters from the top, and she wants to know the height of the falls based on knowing that distance and that angle. Okay, so obviously this formed a 90 degree triangle, so that's what we want to know, the height, h. So this is the angle of interest because they gave it to us. So based on that, well, this is the opposite side. This is the hypotenuse because it's opposite the 90 degrees, and that makes this the adjacent. Okay, so what ratio are we going to use here? So I'll write out my SOHCAHTOA. Okay, now they've asked us for this, right? So definitely opposite side will be involved, and the other side has to be something we know the measurement of, so that has to be adjacent. So it's OA or AO. That's going to be tan ratio. So start off. So tan of 70 degrees is equal to opposite over adjacent. Okay, and now we know, well, the opposite, that's our H. The hypotenuse, adjacent is 14 meters. Okay, so, luckily the H is on the top, so that means we can just multiply both sides by 14. So 14 times tan 70 degrees is equal to H. Okay, so this one, we just go back to the calculator. This time we're using tan. Okay, so make sure we're on. Well, I'm going to take the second function off from the last question because I know I'm going to use tan button. So I'm going to do tan of 70, 70 tan, and then times 14. So that gives us 38.46. And it says to the nearest meter. So do I keep it at 38 or bump it up to 39? Well, it's going to stay at 38 because that's a 4. So it's going to be 38. That's meters. Therefore, the height of the falls is 38 meters. Okay. Hopefully that one seemed, more normal, more like the first couple of questions we did. Okay. And this one is a wheelchair ramp, so they've already got a triangle for the wheelchair ramp. Elena is building a wheelchair ramp to a deck that's 90 centimeters high, so there's the height of the deck. The angle between the ramp and the ground must not be greater than 6 degrees. So this, it's hard to put the angle in there, but that's 6 degrees inside there. And we want to find the minimum allowable distance, horizontal distance, D, between the start of the ramp and the deck to the nearest tenth of a meter. Okay, so let's label our triangle. So there's the right angle, so that makes this the hypotenuse. There's our angle, 6 degrees. Opposite that is our 90, so that's opposite. And our D is our adjacent side. Okay, so definitely want to have this because that's what we're being asked for. So A will be part. SOHCAHTOA. So A is part of it, and the other side has to be a side we know the length of, so it has to be opposite. So it's O and A again. So we got another tan question. So tan of the angle, 6 degrees, is equal to opposite over adjacent. Tan 6 is equal to, what do we got? Opposite is 90 over D. So this is kind of like the question, I think it was question 3 maybe. We can't just multiply by 90, that's going to make it worse. So we're going to multiply first by D on both sides. So we get D times tan 6 is equal to 90 over D times D, so the D's cancel. So I get 90 there, and then I divide both sides by tan 6. Okay, and now we go to the calculator. Okay, so again, this is one that I would do the brackets. Let me move this up so I can see the calculator. Okay, so I've got 90 divided by, and then I put brackets, left bracket first, and then tan 6 degrees. I enter that as 6 tan, and then the right bracket, and then equals. Okay, and I get a pretty big answer here, 856. And I'll round that to 0.3. Now what's the units for this? Because it says to round to the nearest tenth of a meter, but are these meters? No, they're not, because the unit of that 90 was 90 centimeters, so this is centimeters. Now if you remember, how do you convert centimeters to meters? Well, you divide by 100, so it's going to be 8.56 meters. Okay, and it says to the nearest tenth, so when I do my final word answer, therefore the horizontal distance must be, I'm going to leave a space here and we'll talk about it. So when I round that, that's going to be 8.6 meters long. Now the question didn't say, it was kind of a weird question. It said find the minimum allowable distance. Okay, so what's the smallest it can be? Because the question said the angle must be no greater than 6 degrees, right? So if the ramp is 8.6 long, that will make it exactly 6. So if I made it shorter than 8.6, hopefully you can see as you move it closer and closer, that angle will get steeper and steeper. So making this shorter than 8.6 will make the angle bigger than 6 degrees. So, but if I made the length more than 8.6, the angle will get smaller. So I just put the words must be at least, because it could be more. If it was 9 meters, it still satisfies the safety requirements. Okay. All right. One more question, and then we're done. So this one's got another diagram, so that's good. A tower. So here's a hydro tower here, supported by a wire. The wire is attached to the tower at a height of 19. So this triangle here, that's where the wire is. So the wire goes from the tower to the ground along there, and the height of the wire is 19 meters from the ground, and it's 8.1 meters horizontally from the tower. Okay, so you can see I've got a triangle here with a 90-degree angle. I've got this side's 8.1 meters, this side's 19 meters. So what are they asking? They're asking calculate the measure of the angle formed by the wire and the ground. So is that going to be this angle or this one? So the ground is here, wire is there, so there's our angle. You can call it whatever you like for a letter. W is perfect. I'll use theta. Okay, just because it's a good variable for an angle. Now, let's name the sides. Now that we know that's our angle, well, this is hypotenuse all the time. This is the opposite side. This is the adjacent side. So when I'm considering which ratio to use, hopefully you know, it has to be the ratio with the O and the A. So that makes it the tangent ratio. So when I write the equation out, it's going to be tan of the angle, which we don't know, tan theta, is equal to opposite over adjacent. So opposite is 19 meters, adjacent is 8.1. Okay, now this is our second question where they're asking us for the angle. So hopefully you know what to do here. We're going to do the tan inverse of both sides to get rid of the tan here. So I'm going to put tan inverse of tan theta is equal to tan inverse of 19 over 8.1. These cancel each other out. Okay, so now let's try that in the calculator. Hopefully you'll know a little more how to do this now. Okay, so first thing we have to do, well, I might as well get ready. I'll set this to so that the tan button becomes tan inverse, and I don't have to worry about it. Some calculators you don't do that. You'll do the second function just before you press the button. So try it out on your own, see how it works. So the first thing we're going to do is this 19 divided by 8.1. 19 divided by 8.1. Don't forget to press equals. And now we do the tan inverse. So it's already set to tan inverse. Press it, we get 66.9. It's saying to the nearest degree, so that makes the angle 67 degrees. Okay. So just finish off with a word answer. Therefore, the angle between the ground and the wire is 67 degrees. Great. Okay, so hopefully that's a lot of examples. I apologize for the length of the lesson, but hopefully we got into a bit of a flow that you can see how we do the kind of the same thing every time. We label our sides, we figure out what ratio we're going to use, and then we create an equation with that ratio with the information that was given, and then we solve for the value, and most of the time we'll put a word answer. Okay, so there are several questions at the bottom here, more than I want you to do for sure, but make sure you can do some of each. I think in the book the first set of questions is just using the tangent ratio, and then the second set is using sine and cosine. That's why usually when I teach this, like, we do the tangent ratio first, then we do sine and cosine, but you can see how related they are. It's just a matter of what side you're using. Okay, so this will be the only lesson of the week. What I'll do is I'll try to post the assignment, say, on Thursday, and you know, you'll still have until Sunday night to do it. And I think next week, since you've hung in here this long, I think we're going to do half of the next unit. We'll do a little bit of factoring, and then that's it for the course. So we'll probably do 2 more lessons next week and an assignment, and that'll be it for the course. Okay, so hopefully that's good news, and I'll be getting your marks to you shortly. I don't think anyone listening right now has any worry of failing the course, but if you want to make your mark higher, obviously work hard on the assignments. Make sure you're putting in a good effort. Okay, thanks guys. Have a good day.